Hello students, this is a video on the topic tests for quant on the Bodhee Prep app. So the basic idea of these tests is whenever you cover the concepts of a topic, you would want to check whether you will be able to use those concepts in an exam or not. That is when you write this test. For every test, there is a video which gives you the solution and a brief analysis of the kind of attempt required for a good score. There are more than 200 such topic tests available on the Bodhee Prep Android app. So make sure you download the app and make the most of these tests. This video talks about the fifth test on the topic polygons. Overall, the test I think was a moderate level of difficulty, 5 to 6 questions out of 8 would be a 95 percentile here, and the attempt time would probably somewhere in the range of 15 to 18 minutes. If we look at the questions, if each interior angle of a regular polygon is 3 times the exterior angle, if exterior angle is x, interior angle is 3 times of x, and we know that interior angle plus exterior angle will be equal to 180. So 4x is equal to 180, x is equal to 45. So the exterior angle comes out to 45 degree. We have to find the number of sides of the polygon. The exterior angle of a polygon is nothing but 360 upon n, where n is the number of sides. This we have calculated as 45 degree. So n will be 360 by 45 or 8. Option D becomes the answer. Again, basic question, application of formula, easy, within a minute and a half. Difference between interior and exterior angles of a regular polygon is 60. Number of sides of the polygon is. Now, if the exterior angle is x, interior angle will be 60 plus x. Difference is 60. Interior angle plus exterior angle should be equal to 180 degree. So 2x is equal to 180 minus 60, 120. X is equal to 60. So the exterior angle of the polygon is 60. But the exterior angle is 360 by n, where n is the number of sides. So the number of sides of the polygon will be 360 by 60, or 6 becomes my answer. Option B. Again, direct application of formula, easy question. Easy question, about a minute and a half to solve. A polygon has 54 diagonals. The number of sides of the polygon is, number of diagonals of the polygon is n into n minus 3 by 2, where n is the number of sides. This is given as 54. So n into n minus 3 will be 108. And now we can either solve it as a quadratic or just work with 108 and split it into two numbers with a difference of 3. So 10 into 10 is 100. Looking at numbers close to 100, 9 and 12 gives us 108. This had not worked, we could have tried 8 into 11, we could have tried 11 into 14 and so on. But the first try, 9 into 12 gives us the answer. So n will be 12, n minus 3 will be 9. Hence the number of sides of the polygon is 12 becomes my answer. Easy question. Even if I solve the quadratic, it will not take too much time. Therefore, about 90 seconds to solve. The ratio between the number of sides of two regular polygons is 1:2. So the first one has x number of sides, the second one has 2x number of sides. Ratio between the interior angles is 3:4. The number of sides of these polygons are respectively. This cannot be the answer, not in the ratio 1:2. Now, the interior angle of the first one will be 180 minus 360 by x. The interior angle of the second one will be 180 minus 360 by 2x. This is given in the ratio 3:4. Cross multiply 180 into 4 minus 4 into 360 by x is equal to 180 into 3 minus 3 into 360 by 2x. So we can multiply this by 180, divide this by 2, sorry. And therefore 180 into 4 minus 180 into 3 is equal to 4 into 2 into 180 by x. minus 3 into 180 by x. So this will become 180 common. For 180 is equal to 180 by x common. 4 2s are 8. 4 2s are 8 minus 3. 8 minus 3 is 5. 180 cancels, so x comes out to 5. Since the number of sides in the first one is 5, in the second one it will be 2x, which is 10. Option D becomes the answer. The question is easy in terms of concept, just the application of formula. The calculation might take some time, so I'm saying overall moderate, about 2 minutes to solve. The sum of all interior angles of a regular polygon is 4 times the sum of its exterior angles. Sum of all interior angles of a regular polygon, the sum of all interior angles is given by n minus 2 into 180. Is 4 times the sum of its exterior angles. Sum of exterior angles of a polygon is always 360. Therefore, n minus 2 into 180 is 4 times 360. N minus 2 becomes 4 into 360 by 180. 2s are 360, 4 2s are 8. So n is equal to 8 plus 2, which is 10. So the polygon has 10 sides, and a polygon with 10 sides will be called a deca 10. Decagon becomes my answer, option C. Again, direct application of formula, so easy question. The name might be a problem, so overall, maybe 2 minutes to solve. The ratio of measure of angle of a regular nonagon to the measure of its exterior angle. Nonagon means 9 sides. So the exterior angle here will simply be 360 by 9, 360 by 9, which is 40 degree. And therefore interior angle will be 180 minus 40, because interior angle and exterior angle add up to 180. So the required ratio of the angle of a regular nonagon 140 to the measure of its exterior angle 40. Divide by 20, the ratio comes out to 7 by 2, option C. Again, these are easy questions, basic applications of formula, about 2 minutes to solve. The hexagon below has interior angles whose measures are equal. A hexagon has each angle as 180 minus 360 upon 6, which is 120 degree. So all of these angles are 120 degree. It is not a regular hexagon, but the angles are given to be equal. The sides of length 10, 15, 4, 18, 7 are known. The unknown length is required. Now here what we do is we extend this side and extend this side. They will meet somewhere. This angle will be 60 because this is 180. This angle will be 60. Now in this triangle, suppose the triangle is ABC. Two angles are 60, so third angle has to be 60. So triangle ABC is equilateral. And since BC is 10, these two sides also have to be 10 and 10. Similarly, extend this side and extend this side. Here also do the same. Since this angle is 120, this will be 60. This will be 60. And since in this triangle, two angles are 60, the third has to be 60. Suppose we call it PQR. Triangle PQR is also equilateral. And suppose this angle is XYZ. By a similar logic, XYZ will also be equilateral. 60, 60, 60. And therefore, these three sides of PQR will be 7, 7, and 7. These will be 4, 4, and 4 because YZ is 4. Now, if you look at triangle A, X, P, here also all the angles are 60 degree. So, AXP will also be equilateral. So, AX should be equal to AP should be equal to XP. AX will be 10 plus 15 plus 4, 29. AP will be 10 plus the value that we have to calculate, CQ, plus 7. XP will be 4 plus 8, 22 plus 7, which is 29. And therefore, CQ plus 17 is equal to 29, or CQ is equal to 12. That becomes my answer. I will call this a difficult question. Once you're able to see the equilateral triangle, it should happen quickly, but otherwise, uh, uh, understanding or visualizing that construction may be a challenge or difficult question. Find the area of a regular octagon inscribed in a circle of radius 10. Octagon in a radius. Here we have an octagon. Let us draw diameter and equally divide. Something like this. There was A, B, C. These are all straight lines. D, E, F, G, H. Octagon in a circle. Radius is 10. Now what we do is we join, suppose the center is O and H. OH and OA I have joined. So we get a triangle here. Triangle AOH. It should be obvious that there will be 8 such triangles formed. 1, 2, 3, 4, 5, 6, 7, 8. Area of the octagon will be nothing but 8 times the area of triangle AOH. Now for AOH, side AO is 10, OH is 10, both are radii. What will be the angle here? Because it is a regular octagon, this entire angle 360 will be divided in 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So this angle will be 360 by 8, which is 45 degree. And therefore, if we talk of triangle AOH, OAH, OA is 10, OH is 10, and this angle is nothing but 45 degree. Therefore, we can say area of triangle AOH will be half AO into OH into sine O. Half AB sine theta. Or half 10 into 10 into sine 45, which is this 50. Sine 45 is 1 by root 2 and therefore 25 root 2. This is the area of one triangle. Therefore, the overall triangle or area of the octagon will be 8 times 25 root 2, which will come out to 200 root 2 inches square. Therefore, answer becomes none of these, option D. Again, if you are doing it for the first time, it's a difficult question. Drawing the figure and then using AB sine theta. If this is a question that you've seen, then probably about 2 minutes to solve. If you look at the overall test, easy to moderate question, I'm looking at about 5 to 6 questions. For me, they would be 1, 2, 3, 4, 5, 6 essentially. Which are these questions? Formula based, therefore attempting formula based. Again, formula based. So attempting formula based, attempting formula based, attempting question, formula based, attempting question. Here construction is required. May not strike me in the examination, so not a sure shot question for me. Similarly here, sometimes not able to draw the figure and therefore not a sure shot question. My 6 easy questions would be 1 to 6.